For section 7.2, part 2, we're going to bring this full circle. So last section we really worked on finding an LCD, and we talked a little bit about the process of adding and subtracting rationals. Now we're going to put it all together. You're actually going to find a common denominator, rewrite the fractions, and add them all the way across. We're going to complete this full circle. All right, for our first example, we're going to start off with a pretty simple one. I'm going to give you 5 over 2p plus 3 over 8p. Now the first step is going to be to find the common denominator. So it looks like I've got a 2p and an 8p as my two denominators here. So what I'm going to want to do is, these are monomials, so I'm going to start by looking at the numbers. So between a 2 and an 8, I want to ask myself, what number can those both be? In other words, what can they both become? Well, they can both become a 16. Excuse me, that is so incorrect. They can both become an 8. You want the smallest number that they both can become. They can both become an 8. And then you look between a p and a p and you want the biggest one. Well, p to the 1, p to the 1, the biggest one is p to the 1. So in this particular case, my LCD is 8p. So I'm going to come back over into the problem, and I'm actually going to write that 8p on the bottom of both fractions. Remember, the goal is to rewrite both of the fractions with the same denominator. Now what I've got to do is take these fractions and make them equivalent down here. So for example, if I went from a 2p down to an 8p, I actually had to multiply by a 4. I had to make the bottom of this fraction 4 times bigger to become an 8p. Well, if I had to make the bottom 4 times bigger, I have to make the top 4 times bigger as well to keep it equivalent. In other words, 20 over 8p is the same thing as 5 over 2p if you reduce it. Now let's look at our second fraction. I went from an 8p to an 8p. I actually didn't change anything. And in that case, I don't need to change my numerator. It just stays a 3. Now that I've rewritten both of these fractions as equivalent fractions, we're going to go ahead and use our adding process that we did last section. We add the numerators, 20 plus 3, 23. We carry over the denominator of 8p, and then of course we try to reduce. Well, a 23 and an 8 don't reduce, so I am finished at 23 over 8p. Okay, for our second example, let's go ahead and look at something with a polynomial. So I'm going to take 1 over q minus 1, and I'm going to subtract it from 1 over q plus 1. So remember, the first thing that we want to do is we want to find our LCD. So we're going to look at those denominators. I'm going to pull those to the side. I've got a q minus 1 and I've got a q plus 1. Between a q minus 1 and a q plus 1, those are both polynomials. First thing we do is try to factor them. Well, neither one of these can factor. They're both linear and there's no GCF. So I've really got a q minus 1 and a q plus 1. Then we start to look for multiples or repeated things. There is no repeated thing. One's a q minus 1 and one's a q plus 1. And remember, if you remember our rule of thumb, whatever we're left with after canceling those multiples happens to be our LCD. So in this case, our LCD is q minus 1 and q plus 1. We just use one of each. So I'm going to come back over here in the problem. And remember, I want to rewrite both of these fractions with that common denominator in the bottom. Remember, we can't add or subtract until we've got that common denominator in the bottom. So let's go back in here and look. I'm going to start with this first fraction right here. I took q minus 1 and I made it q plus 1, q minus 1. Well, I already had the q minus 1. I added a q plus 1. So since I had to multiply by a q plus 1 in the bottom to get it to look like this, I'm going to multiply by a q plus 1 in the numerator. Well, what's 1 times q plus 1? It's q plus 1. Let's look at the second fraction. I'm going to look over here. For the second fraction, I had a q plus 1. I ended up multiplying by a q minus 1. If I multiply by a q minus 1 on the bottom, I've got to multiply by a q minus 1 in the top to make sure that I've got equivalent fractions. 1 times q minus 1 is just q minus 1. Now I'm ready to actually put these fractions together and make this more simplified, thank goodness. So if you remember correctly, we carry over that lazy denominator and we go ahead and just add or subtract the top like normal. So it looks like I've got q plus 1 minus q minus 1 over q minus 1, q plus 1. Now, I want to point out a couple things. First of all, I put this in parentheses. It wasn't in parentheses here. I put it in parentheses here. Why? Because it's minus. It's minus the whole thing, not just minus the q. It's minus the whole thing. We're eventually going to have to distribute that negative sign in. The next thing I want to point out is I cannot start factoring like a crazy person. Remember, we can only cancel factors. These are not factors. This is minus something. I can't cancel that. A factor is something times something. This is something minus something, so I can't cancel that stuff. I'm going to go ahead and simplify the top of this. The first thing I'm going to do is I'm going to distribute that negative sign in, giving me a negative q and a plus 1. And I'm going to go ahead and try to put some like terms together. So I've got q minus q, well those cancel, and I've got 1 plus 1, that becomes a 2. Then I'm going to carry over that common denominator and see if there's anything I can factor out, and there's not. Q minus 1, q plus 2, q minus 1, q plus 1 stays that way, giving you that as my answer.